Hello, Algebra 2. With this video, I want to show you how to show your thought process with applications. We've talked about showing your thought process with equations, but now we're going to look and see how word problems play in. So I'm going to do number 49 on page 23 in your book. We worked on this in class last week, but let's just have a review. Walkway construction. You are building a walkway of uniform width around a 100 by 60 foot swimming pool. After completing the walkway, you want to put up a fence along the outer edge of the walkway. You have 400 feet of fencing to enclose the walkway. What is the maximum width of the walkway? And here we have a little picture here. Now, a common misunderstanding and lots of questions that I got was, well, this must have something to do with the width or the walkway, those 3 units. It doesn't. That's just a coincidence. They're just trying to make a difference between the walkway and the pool so you can see where the pool is, where the walkway is, and then where the fence should be. So just initial thoughts looking at this picture. There's different ways that you could look at this problem, but I think that the best way to look at it is to think of the fence around the outside of the walkway is like the perimeter of the pool plus another x, 2x. Here, see that 2x? So we're going to take the width or the length, add 2x, and then the width, add 2x, and then find the perimeter of the whole. I'm just talking you through what we're going to do. Notice I covered up the answer, so you can't see what the answer is yet. Let's go back and see how we would put this on our paper. First, we would redraw the picture so that we can interact with the picture, add stuff that we wanted, make it big. We want to make it as accurate as the original. Sorry, not very accurate. There's the pool. It's 100 feet by 60 feet. There, that's a good drawing. Now, we want to think about defining our variables. Here we have x, so we should already know that our x is defined as the width of the walkway. In fact, in the word problem, they use this term maximum. Now, this term maximum width of the walkway means that in order to put the fence around, if you made this a little bit smaller, you wouldn't use all your fencing. But since you bought all the 450 feet of fencing, you kind of want to use all that. You don't want to waste any of it. You bought it for the pool, so you don't want it lying around in your yard for years and years to come. So, we have x as the width of the walkway. Now what we're going to do is see how x is related to the perimeter. Okay? So we're going to look at the perimeter of the pool, perimeter of the walkway. First, let's just look at the perimeter of the pool. Now here, I may use this information, I may not. It may be part of it. It might not be my final equation. But I'm just going to look at the perimeter of the pool to see if I can get some more understanding about this problem. So the perimeter of the pool, remember, if you're taking perimeter, you're going to take twice the length, twice the width, and then find that value. So that's 200 plus another 120, that is 320. Okay? Now, that doesn't really help me because now I just realize, oh gosh, I only have like up there. Oh, look. Hey, I need to add on this extra bit right here. I'm going to add on another x right here so I can really see that if I wanted to actually add on the width of the walkway to the dimensions, it's like I'm taking the dimensions of the pool and then expanding it out to the dimensions of the fence. In order to expand it, I have to expand it by adding 2 x's, or 2 widths of the walkway. So I've seen people do this in different ways. Some people take this value and then fit in adding in this extra bit, but I think the best thing to do is take this idea of the perimeter of the pool, but now let's take the perimeter of the pool and add on these x's. So now if we take the perimeter of the fence, perimeter of fence, and now we're going to add on the 2x to each of the dimensions. So we still have our 2, but now with our length plus another 2x to indicate the width of the walkway, then 60 plus another 2x. Now, what should the perimeter of the fence be? Well, the fence, we want it to be 450. So we set this equation equal to 450. Now we have an equation. We see how x is related to the perimeter of the pool, which is the information we're given in the drawing. We have that the perimeter of the fence also is 450 as a length. So we're seeing the length is equal to the perimeter. The amount of fencing is equal to the perimeter of the pool plus the perimeter of the walkway. Let's solve. We have 200 plus 4x plus 120 plus 4x equals 450. Now look here, we have this 320 that we got from before, but now we're going to add on 8x, and I think what maybe a common mistake would have been, if we didn't include this in the original perimeter, maybe we wouldn't add enough x's, because we can see with the perimeter we need to add 2. I'm saying the same thing over and over again, and that's not a mistake. I really want to emphasize that you really have to look at your situation and make sure that your equation correctly reflects that situation. Subtract 320 on both sides, and we have 8x is equal to 130. I hope I did that right. And finally, dividing by x. We need to show our thought process. We need to have our structure in place as well. And we have that x is equal to 16.25. Now, you might be tempted to stop there and say, oh yay, I found the x, woohoo! But we need to think of the answer in terms of the original problem. So let's look back on the original problem. Okay, x is the maximum width of the walkway. So we want to say our answer in some way that reflects back to the situation. So we say the maximum width of the walkway should be 16 and 25/100, or you could write 16 1/4 feet in order to use all of the 450 feet of fencing. And what's nice about the way that this is written is that we really show that the maximum width means we have to use all of the fencing. Yay.